All right, let's get started here. We are going to be working on the Linux automation course. This will be Unit 1. And I am going to start the course as soon as I get my phone to go on mute. Jeez. It's still over there vibrating. All right, so we're doing Linux Automation Unit 1. We originally did this on September 20th, and I am now recording this for the internet and for people that missed it. All right, so let's get into it a little bit. We always have any questions you have for me, ask them down in Discord. Just message me down there. I'm going to be mostly ignoring chat during this, and I have all my messaging off down there, so we're not going to worry about any of that. This is our first class meeting. If we had any reschedules, they would go here, and I do want to let you guys know on October 4th, so that's the next weekend, so that'll be the third meeting, we're not going to meet. We're going to skip that one, and then we'll come back around to it after, because me and the wife are going to go up to Montana. All right, so let's review the syllabus. I've got a bunch of stuff in here for us to kind of talk through and look at. And here's the syllabus: ProLUG, Professional Linux Users Group 101, Linux Automation for the Enterprise. And here's our course description. The course is going to address how to automate Linux in a corporate environment. I will show you all the things I know about automation, but you will find that, this isn't a course on, becoming an expert in everything in all the world. What this is about is how I apply automation to build servers, keep them updated, make changes to them that are fundamentally sound because they've been tested in lower environments and those kind of things. We are going to adhere to CI/CD principles as best we can, and we're going to work on all of this stuff. All right, so this course will focus on taking the design, build, deploy, administration, and remediation tasks and turn them into automated processes. Why is that? Well, because as systems engineers, there's two core problems that we're going to talk about around doing any type of work, right? So we'll get into that. The emphasis will be on integration during the build run and end-of-life phase so that CI/CD can occur and deployments as code are utilized within our systems, right? So if I build something and I go to build it again and I go to build it over here, it's always exactly the same. And if we need to, we can customize like a configuration file, so then things change as needed between different environments with the same code, right? The same base code. Learner will practice securely building, deploying, integrating, and monitoring Linux systems in an automated fashion. So that's what we're going to be doing. All right. It's a 16-week course, so it's about 160 hours, about 10 hours a week of worksheets and labs and discussion posts. You do have to do the discussion posts if you want to participate in this. If you want to get the cool little certificate at the end. We have a cool little certificate that we give, and then people can actually verify that you've gone through the course by going to our website, and we control that. Only one of our guys can publish that, and then only one of our guys can generate that, in fact, and then only I can publish it. So there's like a lot of control around those certificates. Like nobody could get those that didn't go through the course. All right. Well, nobody would be able. You could probably generate one, but you couldn't validate it. So there's that. Here's the major instructional areas. So automation tools. What is an automation mindset? How does the security engineer focus on these things? How does the continuous integration, continuous deployment, maybe what some people might think of like a DevOps guy, what is he focusing on? What is operations or administration focusing on? These are different job roles, but they're all things that you need to understand if you want to get good at this. And I mean, maybe you find yourself all in systems engineering world like me, where I'm building things and deploying things and making them all the same. And then I'm updating them or changing them, but I'm doing it across all the servers. And then maybe you're over here CI/CD, where you're working for teams and you're quickly deploying and standing up environments for them, right? And they need to tool things quickly to do a different deployment on a different type of, right? That may be, it depends where you're going to find yourself, right? But I try to get you guys ready for all the things that I've seen. We're going to do system building. We're going to build, we might not build servers out, but we're definitely going to build out Docker images and be able to pre-bake them versus changing things as they go and get deployed. So we're going to learn about that. Then we're going to update systems and do software package deployments, network configurations, and system checking and reporting. And some of this stuff you might go, well, Scott, didn't we do a lot of that like in the security and the automation course, or in the administration course? And the answer is yes. But now we're going to do it with an automation focus. But yeah, the things that we do are the same things. It's just we're looking at them a different way with automation as the focus. Here's our course objectives. I always tell you guys, I tell my college students the same thing. The course objectives that we do are these are like my contract to you. These are the things I should be talking about. These are the things that we should be focusing on in here. These are the things at the end of the first week you should feel like you've looked at the various tools for automation and know how to deploy them and at least execute them in an environment. That's all I need for this week is get people in the system, execute it, right? Eventually we'll get into making API calls and maintaining system inventories and environments to, again, do deployments in different similar ways around the environment, depending on what variables you're given and different customizations and things that need to be built into it, right? There's all kinds of things that we can do there. In fact, when we get into the Ansible piece, Ansible can take variables in from like 22 different places, so you do have to learn the variable precedence a little bit, but it's not too difficult, but it's a good thing to understand. We're going to know about the automation mindset, and we're going to try to think about where we should be making things work better and where we want to, again, avoid those two problems, those main problems of people being involved in systems engineering. CI/CD, deploying with automated tools, all these things. I'll let you guys read these. These are published already. But then we come down here, and the resources you're going to need, you could use a cloud server up on Ubuntu or Killer Coda if you wanted, as long as you have at least 2 nodes, right? So if you're in one of the 2 nodes environments, that'll do it. You can run your own, and people were actually asking me about this earlier. What's the minimum you would need? You would need 2 machines, and they can be running RHEL, Rocky, Fedora. I guess you could do Ubuntu or Debian if you wanted to, as long as you can SSH over and they both have Python to execute on them. That would be fine. And then we have the ProLUG Rocky 9 instances, but these are they're Rocky Linux 9, and then they're called the auto servers. So when you jump into our lab environment, you would drop down into the automation labs, right? Those are going to have a definition of target nodes for each of them, and I'm going to give you the mapping of that, and then that's also going to be published up in the book here soon when I send this over to the guys. This is inverted, so this would normally be dark, but you come off the internet, you hit port 22 on our Bastion system, which is ProLUG at prolug.asuscom.com. You get dropped into the jailed environment and you pick any number of servers that we have, right? Currently, we have the administration course, the security course, and the automation course running. The admin course isn't running right now, but there's still 2 nodes up if people needed them for overflow. Instructional methods, I'm mostly going to talk. You guys are mostly going to listen. Then you're going to get in groups and you're going to work on stuff and do stuff that's interesting to you. And again, as with all things, you know, you can do as much or as little of this as you want. I can't make anybody do this. I can't make anybody go do the discussion post. Just like I could probably drag, I'm going to be honest, you know, I'm Brazilian Jiu-Jitsu black belt. I could probably drag most of you to the gym, but I couldn't make you do any lifting if you didn't want to. So, you know, yeah, you know, it's the same thing here. I'm not making you do anything. If you guys choose to do it, this is how you're going to do it. We're going to focus on the explore, practice, apply methodology, where we're going to explore and talk about things. I'm going to give you guys sessions like this and then spin you off on all these different worksheets and other stuff to study. You're going to practice and get skills by getting your hands on the keyboard. And then we're also going to talk about how that works with enterprise, right? So we got to understand a thing. Then we practice it to get some skills, kind of like if you ever played baseball or something where you go practice your individual skills of throwing and fielding, and then you go and you apply it to real life. And really, at the end of the day in the technical world, we could sit here and talk all day and I can show you guys all kinds of things, but if you can't convert it over, if you can't get that last little bit to actually do it when it matters, then everything I showed you and everything you learned was for naught, right? And I don't want that to be the case. I don't want for naughty. My closed captioning is already getting me in trouble. I said for naught. Anyways, the class can do 100 to 200 people. We had about 40 people say they're coming. It's free, so it's up to you if you want to do it. Here's our schedule. We're already done with Unit 1. Well, we're in the middle of Unit 1 right now, so people that want to follow along can. And then we're just going to keep adding more and more to this as we go. So that's our syllabus. Suggested learning approach: show up, talk to people, make friends, make enemies. You can make enemies. Excuse me. Man. I did just get done talking to my college students for an hour or two. So anyway, so that's our suggested learning. We're going to meet over kind of brown bag sessions 1 time per week, and then a total of 16 sessions. So that's our syllabus, okay? That is published through, we actually have that linked down in our Discord. under the beginner start here section, and I will get that book in there linked once we get like a permanent way to get over there. All right, so now let's review the project. We are going to do for this project, and now that I'm getting here, I realize that I actually still didn't write this up. The project that we're going to do is we're going to set up one, actually it is already set up. The guys built it, so I have it down here. Give me 1 second. Pull it up here. Where's that at? I think they dropped it in. It'll be linked down in the Discord either way, and it'll be part of the book, so you guys will be able to see it, but we'll just talk about it for now. So what the project's going to be is we're going to build a automation toolkit, like a little automation toolkit for the group. And if you are working on a project, if you get dropped in somewhere, if you want to download the toolkit, you know, if you want to get it off of Git and pull it, you can do that. And then you could use those tools that you understand and have worked with to deploy things or build things or whatever in an environment. It'll just be a bunch of like more coherent setup of an environment based on the things that we do in this course. And we're going to work on it together. It's going to be one, it's already built, it's a GitHub repo, and anybody can contribute to it. Anybody can work on the different pieces of it, and we're going to get that codified down. So I was saying by like week 3 we'll really start focusing on that. But I want you guys to know that there is a project. You do have to do a project for this course, and it will be contributing to that. All right. So let's get into a little bit this week. We have discussions. You have 1 post and 1 response due before the next Saturday if you're doing the course, right? The first question of the course is, what is automation? And then there's a bunch more to that, but what is automation? And then the second post is, find a blog with topics of triggers and automation, and how do triggers affect automation, and how does testing guide automation? Those are 2 things that I kind of ask in there, and we're going to look at that a little bit more when we get to the worksheet. But then we got a worksheet where we're going to take notes and review materials for the week and all that kind of stuff, and that's one of the things that's actually a deliverable for the course. You would do all your worksheets, put them up in a GitHub, Markdown, something like that. And then the lab, we're ensuring that we have access to all of our tools. That's all we're doing this week, get access, and validate that we can execute all of our tools. If we can do those 2 things, we're ready for the rest of the course. If we can't do those things, we got to go into some other field of work or something. All right, course objective, deploy various automation tools for engineering and operations activities. That's what we're doing this week, right? Okay, so when we drop down here, overview, what is engineering? What is automation? What is a trigger? What types of triggers are there? What is the difference between an event and an alert trigger? If we're making that distinction, what's the difference? And then what tools do we have for automation? What's an automation mindset? And why do we want to cultivate that automation mindset? So let's get into that a little bit. So to back up all the way and level set engineering for everybody, engineering is, it's a science, first off. And science explains the way that the world works through something called the scientific method, right? That's make an observation, ask a question. That's a deductive reasoning method, by the way. You watch things first, and then you make you ask a question about it. You form a hypothesis, make a prediction, and test, right? These are ways that we can know things, right? Then we iterate over it to keep finding more and more things. So engineering is scientific method being put into real practice. And the way we put the scientific method into real practice, right? Again, that's the method, is we do things and build things that cycle, things that walk through a set of steps to completion or breaking, and then we can go look at why they broke and all this stuff. So here's an 8-function cycle over here on the left of something that's doing something. We can understand that engines always have some type of input, they do some type of process, and then they give some type of output. Now, some of you that are more astute might look at that and go, well, didn't you just define computer science? Yeah, computer science is an engineering field because it's a system that cycles. And since it's cycling, that's going to be, everything is an input, a process, or an output. Now, you might say, okay, you input from some different space, sure, and you processed, sure, on a processor, or you did it on some other type of processor, sure, there are always different things. And then output might have stayed in memory or been written down to a channel path that went out to a disk, sure, right? Like, there's all kinds of things that can happen, but they're cycling. That's an important thing to understand. And then we as systems engineers and as process engineers, we have inputs, process, and outputs, but then we talk about suppliers and customers, which are another variable of problem where can the supplier properly put an input, fill out a form? Can the customer properly take the output of JSON and do some parsing of it or not? And then now we have these other variables to think about. And I say that any deviation from a normal acceptable process is the enemy of engineering. If something in here moves outside of the upper and lower control limits of whatever the output is from that thing, it can affect the other things from working properly, right? Now, this is not directly the engineering course. I have a talk that goes heavily into this. It's my why engineering talk, but this is a level set before we get into automation. All right, so automation is an extension of that cycle, right? That cycle is going to happen, right? Engineering is going to happen, and we're going to have triggers that are going to cause events to cycle instead of manual intervention. That's what automation is going to be for us. And it's important to accurately break down each step in a process to be able to properly implement automation. If I want to kick something off, but I don't know that all the pieces are there, it may break somewhere along the way, right? Automation always starts somewhere, mostly at the beginning of a cycle, if it can, but sometimes in the middle, and it must perform all actions unprompted, uncorrected, or realigned. Nothing can affect it because it has to run through to completion by itself. That's the thing to know. All right, so that's my definition of automation for the course. Triggers. Triggers are things that can kick off an automation or a cycle, right? Time can do it, and there's two ways that time can be measured in this sense. There's chronological time, so every morning at 5 a.m., and some of you might very quickly go, well, hold on, isn't that like cron, like the cron tool? Cron can be used for that. System D timers can be used for that too. We're going to use both of them in this course. But chronological, we kick things off. We can also use epochs or spans. And epochs or spans are how much time since the last run. You know, something kicks off, an hour after the last one finished or whatever. Well, there may be a reason to do that. Maybe there's a reset time. Maybe there's a cleanup time. Maybe we want a back off timer, right? So epochs or spans of time can be defined too. We can have event-driven triggers. So events are discrete occurrences within a system. And some of you that did the security course remember that events also cause logs to be written, and logs are discrete occurrences within the system that are immutable, right? But events themselves don't have to be immutable. They're just something that happened. And we can have event-driven system design. So we could be throwing events into a system bus or some kind of Kafka bus or whatever tooling we're going to use, right? And code commits can be events. There could be, I'm giving a few examples. There could be so many types of events. And then there's alerts. Alerts are typically when some threshold, a high water mark, timeout of some other thing happens, typically from monitoring events, right? So events are going along, doing things, and then if we trigger an alert, the difference between an alert and an event is an event, if something happens that doesn't normally happen and that triggers our system to run through a process, that's fine. But if maybe an alert is generated because there's more than 100 events of a type in an hour or something like that, that could be something that triggers. And I always tell people alerts are when the system can no longer handle or contain something and we have to send something outside of the system. So when we did the security engineering course, alerts were always, there's something wrong in the system and we need to send it up to higher. It can't just be monitored inside the system anymore. It needs to be sent out. And a good way to kind of think of an alert is if any of you have ever boiled a teapot or tea kettle or whatever you guys want to call it. And when that thing can't handle the pressure inside of it anymore, it starts to send a signal out. And we just use the fact that 212 degrees or 100 Fahrenheit or 100 Celsius or 212 Fahrenheit will cause water to under pressure changes, I guess, but boil. And when it boils, then it starts to push out and there's steam, right? I know it's different under pressure, but that's fine. So triggers, the tools we're going to use, common automation tools, we've got Bash, Python, and Ansible. Those are going to be our three major ones that we use in the course. We are not going to use all of them every day, but I'll try to work them all in. They're all going to be useful for you. A lot of you already use Bash a lot because that's how you interact with Linux. And I think that's kind of an important thing to understand. All right. So an automation mindset. So what are the central problems of system engineering? What problems drive the need for automation for us? And I would tell you that there's at least two. I'm not challenging you guys to find more. However, if you find more, write them down and send them in and we'll add them, right? But these are the two that I've run into in my career, right? Consistency. If I press a button to build a server, 30 times out of 30 times it needs to be the exact same server. But that's not true if that's going to kick off an alert to ServiceNow and then somebody's going to build it manually. And they're going to use like, you know, John's script, and John's script is changing every few weeks, and there's no, you know, repository or anything like that. But even starting your own process 30 times, if you're manually typing things in, you're going to have issues. If you guys have ever watched me type for more than a minute, you know that I'm making all kinds of mistakes, right? But repeatability and consistency is a big problem in systems engineering, especially when you try to do things by hand. And then the other one is timeliness. The time and variance it takes for people to go through or even get started with a procedure is unacceptable. What I mean by that is, if I can do a procedure in 15 minutes and you can do it in 30 minutes and we get the same relative amount of consistency out of it, that's unacceptable. We should be able to do that probably faster than 15 minutes, whatever it is. But let's say the idea is that, like, if different people are taking different times and that time could be taken away by having a system do it, we should let the system do it. Even if that's going to take a longer period of time, the system will start immediately. I might, you know, finish my bear claw and go and get some water and do some other stuff before I start the process. And then it may take me longer because I get distracted by other things, right? And then that also causes problems. And again, these are the two major problems you're going to see as a systems engineer. And I think an automation mindset can really help it. And then DevOps methodologies, right? These are hardware provisioning of systems or builds of systems, and we tried to turn them into like a software life cycle methodology. And this is a thing that has happened heavily in systems world. We want to turn everything into software as code, right? And everything that we build should produce an artifact, and those are fed into the next step. So as I get my process down for building my servers, and as I build my automation out in this course, each thing should be fed into the next step until I can finally step away and I don't have to do anything except hit a button and it runs. Then that button gets triggered instead of me hitting it anymore, and that trigger can be every morning we build all the servers just to make sure that servers are building properly today. There's no resource exhaustion anywhere. There's no problems with getting to certain things, and then we're good. Acceptance testing becomes automated, meaning we know what all the things we have to do to pass acceptance, regression, smoke testing, all these types of tests that we do. And then we automate that all in so that when we have done a change or done whatever, we run through the process and everything's working. That's one of the things we do. We do peer review before we go into production. So before something switches from dev down to prod, there's always some type of peer review, typically like 2 humans. In the future, I'm sure that'll even get automated. But for now, a lot of people who are risk averse will not just allow things to be pushed up into prod without a human seeing it happen. So dev can always spin. Dev can always be spinning as we make changes and do things. And then when we're ready and validate, we move stuff up to prod so that prod can deploy as needed. Okay. And then we call that sometimes continuous implementation or continuous integration, some people like to call it, and continuous deployment of servers or devices or environments and software, whatever we're doing, right? A lot of times us as Linux admins and engineers, we're building those environments for people. So this is an important thing to know. All right. And then this is one, like, I think people kind of crap on this one a little bit. I don't think that this one gets as much respect as it deserves, but like the quick and dirty one-off commands and like one-liners and what people would call like ad hoc commands in Ansible, they are not to just be like pushed over to the side and be like, ooh, brother, I'm not going to use that. I'll always build a playbook. Well, that's silly. Sometimes there's information that's needed immediately. Manager taps you on the shoulder. He's going to a meeting. He wants it in chat message. He sends you a chat message while he's already in the meeting. Like, the manager can need any number of things. And you have to be able to pull that out quickly and feed it to him in a way that he or she can read, right? So being able to pull one-off information from large swaths of server is going to greatly increase people's perception of your usefulness to them. Now, if people are constantly doing that, you probably need to teach them how to fish instead of fishing for them. But also another way to think of that could be teaching them how to like pull from an API, and then you build an API. And a lot of organizations do this thing called API first, where if somebody keeps asking you something or keeps needing something, or especially your manager keeps asking you something, build a dashboard for him. Why? Let him pull up a cool little dashboard in front of everybody and show them the thing that you built. And then when they need it, they're still going to have to come to you to build it. So That ends up making you more valuable as an engineer to your organization. But you need to quickly verify something. Somebody sent you something about some manager over some team. They built a set of servers and they need to make sure that Tomcat's on all of them. And Tomcat's all the same version. And Tomcat's all working properly with their code, with some little, they give you some little diddle of some code to execute real quick, and you just go run it and make sure all the systems are working the way that you expect. There's a lot of reasons to do quick and dirty one-off commands. I don't ever think you're going to be like, hey, I have transcended all of that and now I only pump out working playbooks and the playbook runs and I sit there like this on my mountain with my fingers up in the air, floating. That's not how it works. So all right, so if you got questions, we'll get to those, but let's go to more of the book. So we did the syllabus, and let's look at the worksheet for this week. So here's the worksheet for this week. This will be published. I'll get this probably to the guys tonight, and then they'll be able to get it into the book, and then we'll post the book link on the thing. But here's the actual discussions, right? Discussions, you have to have two posts. You have to have one answer and one answer to somebody else in each, so it's actually 4 posts, right? I'm a monster, I know. And here's the first discussion question. It's, what is automation? And that's framed against, if you've done the courses before, how would you define administration, right? If you've done the other course on security, how would you define security? And then when you think about automation, how does it tie into things you do on a daily basis, inside or outside of computer systems? So these are the things that you're walking through and asking yourself, and then generating some information about and posting your thoughts out to people. Then you can look at somebody else's and say, I agree with that, maybe I don't agree with that, or could you explain that to me better? People love explaining. Engineers love explaining themselves. If you don't know that, I'd question how much you've worked with engineers, but man, and you really want to get information out of an engineer, quote something back to them incorrectly, like you understood it incorrectly. It might cost you a little cool points with them, but who cares? They will love to correct you. Engineers love correcting things, right? It's like a characteristic of a good engineer. They can't see things wrong. They have to fix them. But especially if you're reiterating something from them that you're going to go tell other people, and they're like, no. All right. And then now we get down into, what is the trigger for an automation? What is your definition of trigger? What are the types of triggers that you can read about or define? And where would you place these triggers to positively affect your ability to build or administer Linux systems? So that's the second one. And there's 2 different discussion posts that you got to work through for the course. There's a bunch of definitions that I think that you should go and spend some time with and understand for your own knowledge, right? This is all part of the worksheet that you would turn in, but you can add more definitions that we've talked about. You could be taking notes and adding things. I think that's valuable. And then here's a bunch of links to things that I think are useful to go see. One of these things I mentioned earlier was serverless land, or I mentioned event-driven systems. And if you want to do event-driven in the cloud, serverless land is a great place to get started with that. And what they do is they use a tool like Amazon Event Bridge or Managed Services for Kafka, which is MSK for them, or in an environment like ours, we just have Kafka. You can just use Kafka, send traffic over to it, and then other systems are listening. There's producers and consumers to that system, okay? Now, we come down here. If you have any terms or useful tools that you want to add to your document, you can. And then we got our lab and assignment. So the thing we're actually doing for this week, again, just getting in and executing systems. I'm going to show you that here in a second. It's to be completed outside of our normal meeting time. So you don't do that while we're sitting there normally. And then digging a little deeper, I tell you to go over to serverless land that I just showed you. Find a serverless architecture in the cloud that you think is interesting and see if you can deploy it. Now, digging deeper is something you can do on your own. You don't have to do it for the course, but I think it's useful to understand. And then I also am telling you that many of the concepts that I'm going to talk about throughout the course are already in our Ansible labs up on Killer Coda. So you could get in there and start working on those as well if you wanted to now. So you could start to really prime all the things that we're going to work through early on in the course if you wanted to. All right. Reflection questions are for you. What do you still have questions about for this week? And how are you going to use what you've learned in your current role? All right. So that's that. And then here's our Linux automation lab guide, which talks about getting into our lab. If you're going to use our professional Linux users group lab, that's fine, but there are some rules in there. Because I mainly have to make rules because you're root, and I need people to understand the seriousness of the fact that if you're given root in an organization, you're already given all the power. Like for me, I never had any desire to mess around or do stuff for the lulls once I had root, because I've already been given root. So I do have an acceptable use policy. You'll see this when you log into the Bastion node. It says you are entering the ProLUG lab environment. All activities may be monitored. I monitor everything. If you guys haven't seen my monitoring, by entering, you agree to use this lab for the stated purpose of learning Linux. Okay. Willful violations of this acceptable use policy or intentional destruction may result, will result in removal from ProLUG. And I'll have a zero tolerance policy for that. So just so you guys know. Here's how you access the lab. You jump into ProLUG app, asuscom.com. Most of you guys know how to do this. There's a whole channel in our Discord for how to do this. And then you get one of the different servers and you jump into lab capacity. If you are doing the automation course, whoops, what the hell just happened? If you're doing the automation course, this is the mapping for the servers. It's auto 1 is going to go to target 1.1 and target 1.2. Auto 2 is going to go to target 2.1 and target 2.2. Auto 3, Auto 4, Auto 5. I don't need to show you guys all that. If you're using the Killer Coda lab, because that's just easier or you want additional capacity, then you're going to have control plane and target node, and you're going to be the root user the entire time, and you're going to have a key. In our lab, you're not going to have a key over to those other nodes. And I did that on purpose, because sometimes you are going to have to use a service account in your duties as an engineer. You're going to have to use a service account to get to certain nodes. And sometimes you might have to use a password to initially connect. For the purposes of this lab, I'm okay, or these labs, I'm okay with you immediately going down there and generating a key and pushing a key for yourself for that service account. That's the only account that'll get in. You can't get in as root on those boxes. So you're going to go in as the service account. But that's also going to mimic the workflow of most organizations. You're typically going to jump into servers as a lower user and sudo up to permissions and then drop down and leave. And that's how a lot of automation occurs in the environment. And there's a good reason for that too, because then I can have different service accounts that have certain permissions, and then I can give those permissions to people in the system. All right. So that's the lab. There's public keys. So if you want to give us public keys so that you can connect into the lab, you can drop those right into the ProLUG lab environment channel, and then I add them in currently manually. In the future, I'll automate it. And then the password method is just unreliable, as I change that password too often. So I don't want to publish that password out there. So we'll just use lab keys for most people. And then when you're done, reboot the servers. You can reboot, just reboot all the way out. You can reboot the target nodes, reboot the auto node, and it'll kick you out of the lab. And I want you to do that because our systems are all stateless nodes, so they take about, a minute and a half. It's about 2.5 to 3 minutes to come back up, and then they act like you weren't even there. It's like a little, doesn't matter. Okay, so then let's go look at the automation. Here's the labs for this week, right? I put the lab together, and again, the lab is the simplest thing. Let's not go there. Let's clear this. Let's go to Auto 5. Here's our auto server. You drop into one of these. And we start with just getting into the environments, Bash, Python, Ansible. Now, you might note very quickly you're already in Bash, but maybe I can say which Bash, which Bash, and then maybe I can say Bash version, right? That's directly from the lab over there. And I can see some information about it. I can see the process ID of the bash shell that I'm in. I can see that the shell thinks that it's bash. Now that's just a variable. We can change that variable, but that's what the system thinks it is. And then if I wanted to, I can hit all the servers in my thing. So I can say target 5-1 and target 5-2. Do timeout, maybe timeout through 10 seconds SSH SVC Ansible at server, and then I can do an uptime, and then done, right? And then maybe, did I not name that right? $. Oh, I did servers. I'm dumb. It's servers here. So now I go to each server and then Ansible 1, 2, 3, 4 for my login. where I log in, and very quickly you would go, well, Scott, that's a terrible way to go roll through a bunch of servers. And I'd say, yeah, you're exactly right. That's not how we would do it. But that is my tool, and that is a way to do it. I could also go take that and drop those names into a file. So I could VI, servers as a file, and then in there I can say target 5-1 and target 5-2, right? And then now I can go here, and right here, instead of a generated list, I could use a list that's pulled from that. So I can say cat servers, right? And that would be the same thing, but then I would still need the password. That's not great. Right? It's not great to have to put in the password like that, especially if you're hitting 10,000 nodes. Like, that would be very quickly untenable. But this is why we go to other tools, right? This is why we have other tools. So now I did that with Bash, and then maybe in this environment I check out Python. I see that I got Python. I can go into an interactive shell with Python, right? Python 3 here, and then now I can import OS, and I see that worked. But how do I know that worked? Well, I could do something broken, like import NumPy. I don't have NumPy on the system, so now that causes a module load error. Okay, can't find the module, so you can't run it. And then maybe I exit, and I say, okay, for now, that's all I want you to do with Python. We're going to do more later, but for now, all you got to do is connect. And then we're going to do a little bit of Ansible executions, right? We're going to see, do we have Ansible on here? We got Ansible. We could say Ansible dash and hit a bunch of tabs, and we have different tools that came with Ansible. That's cool. And then I can say Ansible doc -L, and this will give me a big long list of all of the modules that exist. But I might say, well, I want to count that instead of looking at it like that. So then we count them all. I think it's like 7,800 or so. That's a lot. And then maybe I go look for just copy in my environment and see, can I find the, so it's searching through all of them, and yeah, there's Ansible built-in copy, and then now I can go read information about that if I wanted to. And that's all you got to do for the first lab. I just want to make sure that people can get access to the system for now. We're going to start digging around and going into interacting with the OS and making and using inventories and get further and further into this here soon. But for now, that's all you need to do with that. All right, so what's my timer at? That was only 40 minutes. That's not bad. Let's see if there's anything else that I need to show you guys here. No, that's the whole start of the lab, whole start of the lab book. That is the whole start of all that. Yeah, and we went through everything here for the first week of the course as it kind of exists, and then as we're going to start to progress through it. I think that's a good enough start for everybody. If you have questions, just let me know down in the Discord, and I'm gonna go ahead and call this here, and I will then probably come back on here in a little bit and just do normal Linux stuff. But that's the first recording for the